In this lesson, I'm going to talk about the graphs of even degree and odd degree polynomials. And so let's start with the odd degree scenario. And there's two different cases here. Case one is where the leading coefficient is positive. So an example of a function with these characteristics would be y is equal to x cubed, since 3 is odd, and a leading coefficient has to be positive. So we'll just stick with positive 1 in this case. So if we graph this function using a calculator, I want you to observe the end behavior of the graph. Okay, so take a look at the graph here. Look at what happens to the graph when x gets really big. When x gets really large, this graph is increasing through quadrants 1. Okay, again, when x is decreasing, this time the graph is decreasing as well through quadrant 3. And so this is the general occurrence of odd degree polynomials to the leading coefficient of a positive number. So the end behavior is in quadrants 1 and quadrants 3, and it's increasing as x gets large. Okay, so let's look at the next case where the leading coefficient is negative this time. So this time we're going to work with a polynomial with a negative leading coefficient would be, so let's start with a negative x cubed. Okay, so this time go into your calculator. I want you to erase what you had in there before. And this time you're going to graph y is equal to negative x cubed. So clear whatever you had in there. Negative x to the power of 3. Okay, so look at the end behavior of this graph now. Okay, it seems to have switched around. So when x gets really small, this time the graph is increasing in quadrant 2. Okay, as x gets really large, the graph is decreasing this time through quadrants 4. So the end behavior is in different quadrants. So to summarize this in my lesson here, end behaviors are in quadrants 2 and quadrants 4, and this time the graph is decreasing as x gets really large. Okay, so now let's move on to when the degree of a function is even. Okay, so we're going to take a look at two scenarios. The first scenario is where the leading coefficient is positive. So pick a function where the degree is even and the leading coefficient is positive. Let's work with x to the power of 2, since 2 is even, and we'll stick with the leading coefficient of positive 1. So go into your calculator now, and I want you to take a look at what happens to the end behavior. So clear whatever you had in there. And this time, x squared is the function you want to graph. So once you press graph, you get a parabola. And look at what happens to the end behavior. As x gets really large, this graph gets really large as well through quadrant 1. As x gets really small, the graph also increases, but in this time in quadrant 2. So the end behavior is in quadrants 1 and 2, and that's going to be a general statement for when you have an even degree and a leading coefficient that is positive. So there you go. And then finally, our last case is where the leading coefficient is negative this time. So we're going to graph y is equal to negative x squared. And take a look at what happens when we graph this function. So erase what you had in there. Okay, and plop in negative x squared. So negative x to the power of 2. And look at the end behavior this time. This graph has been flipped. And as x increases, the graph decreases in quadrant 4. Okay, and again, when x is decreasing, this graph is decreasing as well. So it ends in quadrant 3. And that's the end behavior of when your leading coefficient is negative this time. So to summarize it in my lesson here, end behavior is in quadrants 4 and quadrant 3. So you can see the significant differences of when your polynomial has an odd or an even degree, and the leading coefficient also has a huge role to play for your end behavior of the graph. And that is how that is my explanation of the graphs of even and odd degree polynomials.